Okay, so one thing we don't know how to do is we don't know how to take derivatives of functions that require the product rule. I'm sorry, the integral of functions that require the product rule if you were to take the derivative. So for example, look at this. You know, if you want to find the integral of x cosine of x dx, you can't really do substitution, because let's say you say, you choose u to be x. What's the derivative of x? 1. But yeah, exactly. If you truly do substitution, then you get u cosine of u du. Does that help you at all? That's the same darn thing. So we got to come up with a kind of a way to work around this. And this is very important. Okay, I'm going to write this down on top. This is something you need to commit to memory because it's a notation piece that's used often. We're going to call big F the antiderivative of little f. And if you take the derivative of big F, you get little f. Sometimes that's just a way to work around notation when we kind of run out of stuff. And so what I want to do here is I want to use the product rule to derive a method of finding the integral of the product of two functions. So if we've got f times g derivative equals f prime g plus g prime f. Everybody agrees that's the product rule, right? Well, I'm going to actually, I'm going to find a way to, manipulate that so we've got a rule that we can use to find antiderivatives. And here's all I'm going to do. Just for sake of notation, I'm going to substitute big F in for little f. So if I have two functions multiplied together, big F times g prime equals, then, so see if you can follow this, okay? So I would have the derivative of f. What's the derivative of big F? Little f times g plus g prime times big F. So that's my new product rule, so I've just rewritten it. Everybody okay with that step? That one's big. Now, I'm going to take the integral of both sides. See, follow this. The integral of f g prime, that's going to be equal to, I could break integrals up over addition and subtraction. So this will be the integral of this side, which is the integral of fg, plus the integral of g prime f. Now, here's where a few aha moments have to come in. No. Think about it, folks. This is the real key here. What is the relationship between the integral sign and the derivative sign? They are inverse operations. They cancel each other out. So what are you going to be left with here? Big Fg is equal to the integral of Fg plus integral of g prime big F. Yep. Remember when I started out, this was the whole problem, you guys. We want to find the integral of x cosine of x dx. Well, isn't that just a fancy way of saying we're trying to find the integral of some function f times some function of g? We want to find a rule for that, right? Well, I've got that right here, don't I? So this is what I want to solve for. I can solve for this by just subtracting that over the other side, can't I? So I'll subtract that over. I get big F times g minus the integral of g prime f is equal to the integral of the two functions multiplied together. I would have to, no. I could distribute the integral operation over addition subtraction, but not through multiplication or division. if we want to do this, we have to use our technique of integration by parts because we have two things multiplied by each other. The only reason we were able to do it here was because it was the derivative of both of them. It was the product of them. Remember, this is not f prime times g prime. This is the entire product rule. So it does not work out like that. The idea is this. We've just derived a formula. The integral of two functions multiplied together is equal to, as you look at what you have up there, big F, so the antiderivative of F, times G minus the integral of G prime times big F. There's generally, there's some ways to look at this, but two things to look for. Choose F to be something you know the antiderivative for. So very important that whatever you choose F to be, that's going to be the one that you could take the antiderivative of. Second of all, choose G to be something you know the what? Good, the derivative of. And it's good if it eventually terminates. For example, what do I mean by terminate? Well, x to the third, what's the derivative of 3x squared? Or, what's the derivative of x to the third? What's the derivative of that? What's the derivative of that? What's the derivative of that? See, it terminates. Polynomials eventually will terminate as you take the derivative of them. It's very good to often choose those for g. As you can see, I'm going to have to find an antiderivative for f. So that's what we want to choose f to be something you can find the antiderivative of. And then g, you like it if it terminates, or sometimes if it repeats. Yep. So, we'll do a classic example. The integral of x sine of x. We haven't been able to do this up until now, okay? But now we know it, okay? Do you know the antiderivative of x? Yep. Do you know the antiderivative of sine? Yeah, so either one could be f. Either one could be. Do you know the derivative of them both? Yes, but which one terminates? Which one just goes away eventually? X will just go away. So, we're going to choose this to be g and this to be f. So we write it out. The formula says, as you look at it, big F. What's the antiderivative of sine? Negative cosine. Times g. What's g? So we have negative x cosine of x. That's big F times g. Is everybody clear there? Okay. Minus the integral of, what's g prime? 1 times, what was big F? Negative cosine of x. I'll show you. Now we do the second step. We have negative x cosine of x. If you see a negative in here, you can cancel it. So this becomes plus the integral of cosine of x dx. What is the antiderivative of cosine? Sine. If no, well, if I do a proof, I end the proof. I do, yes. But this is just antiderivative. Child's play. If you were to take, now just think about this, okay? If we were to take the derivative of this, what should you come up with? X sine of x. And you're wondering how would that happen? It would happen because if you were to take the derivative of this, you would have to use the product rule here, and then combine it with the derivative of sine of x, which would be cosine of x, and things would cancel, and you'd come up with that. If you don't believe it, take the derivative. But we just use integration by parts. Okay. Flip it over. You don't know what the integral of natural log of x is. Do you know what the derivative of natural log is? 1 over x. Ooh, the integral. But we don't have two things multiplied together, do we? Yes, we do. I remember I was sitting in class. Got a 1. No, I knew I wanted to be a math major when I was born. All right, so we got to figure out f, and we got to figure out g. Now think about this. F has to be something you know the antiderivative of. Do you know the antiderivative of natural log? No. Do you know the antiderivative of 1? Yes. So the antiderivative of 1, so that will be f. Do we know the derivative of natural log? Yes. So that will be g. Derivative of natural log is, okay, so we're set up. 1 will be f, and g will be natural log. We do it. The integral of 1 times natural log of x dx equals big F. What's big F? X. Antiderivative of 1 is x times, what's g? Natural log of x. Then what? Minus the integral of, what's big F? X times, what's g prime? So this is x natural log of x minus the integral of 1 dx. What's the integral of 1 dx? So if you look at your formula sheet, I do tell you what the integral of natural log is. We just proved it. There you go. Sure. Hey, pretty sweet, huh? You guys want to try this one on your own? Oh, all right. All right, which one's F, which one's G? F has to be something you know the antiderivative of. Do you know the antiderivative of x to the fourth? Yeah, and so we're just going to choose this to be F and this to be G because we technically know the antiderivative and the derivative for each one. But as you notice, does natural log kind of terminate? It goes to a 1 over x, and that's going to help some things to cancel. So that's really good for us. Yeah. What's F? Big F. X to the fifth over 5 times, what's G? Natural log of x minus the integral of, what's big F? X to the fifth over 5 times, what is G prime? So we've got x to the fifth over 5, natural log of x, minus the integral of x to the fourth over 5 dx. Do you know what the antiderivative of x to the fourth over 5 is? It's very good. X to the fifth over 25. If you would like to take on an x to the fifth over 25, you sure can do that. Really not necessary. The integral is the antiderivative. It's what we use to eventually find the area bounded by the function and the x-axis. It is how we add up an infinite number of rectangles. Ooh. Little introduction to Calc 2. Okay. What's F? What's G? If G terminates, we want it to terminate because the derivative of 3x squared is 6x, and derivative of 6x is 6, and that's going to be to our advantage. Notice e to the x, what's the antiderivative of e to the x? What's the derivative of e to the x? So it really doesn't matter what e to the x is. It has the same function either way. The question is, do you want to take 3x squared eventually down to 0, or do you want to take 3x squared and move it up? Well, we want to reduce the power of it. So we set it up. The integral of 3x squared e to the x dx is equal to big F. What's big F? E to the x. Isn't that great? Just say it. That's e to the x. Times g, so you'd have 3x squared e to the x. Minus... I think you were getting sassy there. So she sees where the problem's going. She said, do you need your parentheses? Because I took some points off her parentheses. So... integral. All right. What is F? E to the x was G prime. 6x e to the x dx. Uh-oh. You can see that this required, if it was the, what's the antiderivative of 6 e to the x? 6 e to the x. But do you know the antiderivative of 6x e to the x? So we got to do it again. Every year I teach this, that's what people do. It's like, oh no! It's just kind of funny. So, yes, Miss Drescher, we will use our parenthesis. And we'll set it up. Which one should be F? Which one should be G? Yep. So, we have big F times G, which is 6x e to the x, minus the integral of, what is G prime? 6, and big F is e to the x dx. So, do you know the antiderivative of that? Yes, we do. So, therefore, we know that that will be our last stop in here. So, let's evaluate this. 3x squared e to the x minus 6x e to the x plus, what is the integral of 6 e to the x? What's the antiderivative of 6 e to the x? 6 e to the x. Would I dock points if you what? If you put minus? No! I would, if you put minus C, I'd be so proud. Because you understand that the constant, doesn't matter if it's positive or negative, the derivative is 0, yeah. Sometimes, I've gotten students who, when they get to the C there, they'll go like this. They'll go, take that, Mr. Gins. Imaginary? Oh, you want to talk about derivatives of complex numbers. Ooh, not ready for that, Larry. All right. Are you ready for the last one? I don't think you are either. We'll have to do this one on Monday. This one's much more difficult. Okay, your assignment is just to do these 4 problems. Make sure you get them done.